In our last week of new material in Math 95, we'll be looking at solving inequalities. We'll review how to solve linear inequalities algebraically, how to solve compound inequalities algebraically, and we'll look at how to solve different types of inequalities graphically. By looking at the graphs, we'll be able to solve more complex inequalities. Now, a reminder first of what an inequality is. An inequality is a math statement in which two expressions are compared with a less than, a greater than, or a less than or equal, or a greater than or equal. So one of these four symbols. Examples include x is less than 2, x is greater than or equal to 5, 4 minus 2 times the quantity x plus 5 is less than or equal to 5x minus 6, and 10 minus 8x is greater than 26. Just like equations, inequalities have solutions. A solution is the same definition with an equation and an inequality. A solution is a value for the variable that makes the statement true. So for instance, if you have the statement x is less than 2, we're going to be looking for values of x that are less than 2 to be a solution. So for instance, 1 is less than 2, so that's a solution. Not 3, but negative 3 is a solution. Notice 3 would be bigger than 2. So it would not be a solution. I accidentally said 3 instead of negative 3 at first. So 3 is not a solution. So again, you have to be something that is less than 2 to be a solution. But there's lots of numbers like 0, negative 1.5, negative 167, 1.999 is less than 2. And it would go on and on. In fact, there's no way to write these all out in our lifetime. There's an infinite number of solutions. So we have to have a different way of writing them down other than just listing them out. So let's take a look at how we could do that. So there are three common methods for giving the solution set of an inequality. We are going to look at graphing the solution sets on a number line. We'll look at expressing them in set builder notation, and then we'll express the solutions in interval notation. The two most common that you'll see will be the graphical way of doing it and the interval notation. Especially as you continue into higher level classes, you're going to see interval notation used quite a bit. We've used interval notation with domain and range, so it should be fairly familiar. Let's take a look at graphing first, because you get a sense of what the solutions mean. So we had that example of x is less than 2. Remember, we looked at the solutions all being values that were lower or smaller than 2. Well, on a number line, that would be values that are to the left of 2. And what we do to show that in a graph is we just shade the side where we would have solutions. Now, at 2 itself, we're either going to use one of two things, a bracket or a parentheses. A bracket at 2, opening toward the shaded region, indicates that you include the endpoint. A parenthesis opening toward the shaded region means that you want to exclude the endpoint. Now, whether you include it or exclude it depends on whether you have an equals in the statement. There is no equals here, so that means we exclude the number 2. We're only going right up into 2, but not including it. So we're going to use a parenthesis right at 2 on the number line to indicate that we want to include up to 2, but not 2 itself. So this would be this is how we would show our solution set. Now I'm going to skip set builder for a moment and go to interval notation next. And the reason I'm going to do that is that interval notation is a mimic of what we see in the graph. In particular, what we're going to do with interval notation is always start with our low number. In this case, or in the low number would be the number to the left, which would be negative infinity. We'll put a comma and then go up to our highest number, or our number on the right, which is 2. So this is mimicking what we see in the graph, the negative infinity and 2. It's exactly on the same sides that you would see it in the graph. And then with infinity, remember with interval notation, we always use a parenthesis, and with the 2, we are also going to use a parenthesis because we do not include it because there's no equals. Now let's go back and look at the third notation, which is set builder notation. In set builder notation, we have a specific form we write the statement in. We're going to start the set with a brace. We're going to then list the variable that we're working with, which is x. And then this vertical bar is the mathematical way of saying such that. And I'll come back to the full statement in a moment. And then we put a mathematical description of what the variable can be, and that would be the inequality itself, x is less than 2. We close our set off with the brace. So what this statement is saying is the set of x such that x is less than 2. That's what that set builder notation is saying. So 3 ways of showing the solution set for an inequality like this. Let's look at an example. Let's say we have 5 is less than or equal to x. So 5 is less than or equal to x. And I want to show that in a graph, and I want to show it with set builder notation and interval notation. Now, one thing that you'll notice here is that the x is on the right this time. The main thing with an inequality that you want to be aware of is how that symbol, the inequality symbol itself, is facing or opening to the particular numbers. So in this case, it's opening to the x. Whatever number it opens to is the bigger number. So what we're saying is that x is bigger or larger than 5, or x can be equal to 5, okay? So it's important to make sure you understand what that statement is saying. Now, the way I wrote it there, 5 is less than or equal to x, could also be interchangeable with x. If you put it on this side, you need to make sure it still opens is greater or equal to 5. Make sure the inequality symbol, if you write it the other way, still opens to the same number. So in our graph, we would want to have numbers that are bigger than x, or the 5 shaded. So I have 5 over here on the right, so I'm going to shade kind of up past 6 and 8. So I'm going to shade that and put my arrow. And then at 5 itself, because I have an equal sign, I'm going to use a bracket and then shade the set. So that would be the graph of the solution set for this inequality. In set builder notation, I would say the set of x such that, and you could use either one of these 2 statements. Usually we do the one where x is first. Set of x such that x is greater or equal to 5. Close your brace. And then in interval notation, we just mimic what this graph is showing, which is that our left number is 5, our right number is infinity. Always use a parenthesis with infinity, and because we're including the 5, because of the equals, we'll use a bracket.